Hey everyone, Rebel Coder here again. Today we're going back to Rosalind problems. We're going to take a look at Python Village part of Rosalind and solve all 6 problems. So let me switch to the browser here. This is where we left off last time. Now we're going to switch to Python Village. So as you can see, it has 6 problems. These problems are not really bioinformatics related problems, they are more Python related problems. So if you're just starting to learn Python, it is a good idea to go through all of these 6 problems and just to make sure that you have all the fundamentals like dictionaries, working with files, opening, closing, reading, writing from files, conditions and loops, strings and lists, okay? So today we're going to go through each, and most of them are very quick problems to solve, literally 1, 2, maybe 3 lines of code. So let's start by looking at our installing Python problem, which is probably not even a problem. All you need to do is just import module, which we did in the previous videos when we imported random module, collections module. Okay, so as you can see here, that's our stronghold from the last lesson. Here it is. And I've created a new file in Python Village and I called it allproblems.py. Again, we are going to solve all of the 6 problems right here in this file. So the first problem is just importing a module called this, which is a part of Python's standard modules, and let's see what it does. Let's just run it. That is what Rosalind said. Please import this module and run it. And as you can see, it just prints out this output here. So it is some kind of an Easter egg in Python. It doesn't really do anything. Corey Schaefer has a very good video about going into libraries and just looking at how they work internally. So I definitely suggest watching that, and I'm going to link it right now. Okay, so let's copy this text because Rosalind is expecting the output for this first problem. Okay, if we are going to download dataset, the only thing it's going to have is a file which has exactly the same text as this in it. Okay, so let's go into... Okay, so let's copy our text here and submit our solution. Okay, so it is correct. I've already solved all of these 6 problems, so you can do that as many times as you want, and you can, for example, optimize your code and resubmit it or something like that. Okay, so that was quick. Let's take a look at our next problem. We're going to go next. So the next one is variables and some arithmetic. It is a very simple problem as well. All we need to do is we input 2 numbers, a and b, and we need to calculate a square of hypotenuse of the right triangle. If you're not sure how this is done, hypotenuse is basically a squared plus b squared equals c squared, and we need to find that c squared. So we have a sample data set here, 3 and 5, and the expected output is 34. So 3 squared plus 5 squared, it is 34. It is equals to 34. So let's go back to our code. Let me comment this out because we don't want to see that output every time we run our code. Let me save that. And I have a snippets ready here so we don't waste our time looking at me typing things. So, and I will leave comments above every single problem so it is easier to navigate and find the particular problem. Let me save that. So the only thing we do here is we're using our f string. We of course could define result variable and do the calculation right here and then insert the result. Okay, so let's run it. And we indeed do get 34, which is correct. But this calculation is very simple, very small calculation, and it is easy to read if we are going to insert it into an f string. Of course, it's not really a good idea to insert a lot of different calculations here, and if this line gets very long, it's hard to understand what you're trying to do here. So in this case, we can do that. If you're not sure again what f strings are and how they work, they are very powerful and very useful. I will link the f string description right now again from Corey's channel. So let's go back to our Rosalind and ask for a data set. So let's click dataset. Okay, let me save the file. So Rosalind dataset returned 2 numbers. Let me copy and paste them into the code so you can see them too. Here they are. So we are going to replace our A with this and B with this. And as you remember, everyone gets different random numbers. Let's run this and see. So that's what we see as a result. Let's copy this result and go back to our Rosalind and paste it right here. Submit. Okay, so congratulations, this has been solved. So that was yet another easy problem to solve. So just make sure you understand all the fundamentals and basics of Python, and you can do all these very simple things because we're going to be building our code on top of these small things by combining a lot of small bits and pieces. Okay, let's go to our next problem. Strings and lists. This is yet another very simple problem. We are given a string with no spaces, and we are given coordinates of the words we need to find in this string. So this is called string slicing. We're going to tell our code to start from character number 22, and it's going to count to 22, and stop counting at 27, and just give us the word in between 22 and 27, and the second word starts at 97 and ends on 102, so somewhere around here. And that is our sample output, so let's see what we can do in this case. Let's go back to our code. Okay, and I'm going to copy and paste our snippets here again. So let's see what we have here. Again, we have a title here in the comment section. And we have start position and the end position of the first word, and start and end position for our second word. So I copied these values from a example that Rosalind gave us, and that's the example string. Okay, so here again, we don't really need a lot of code. It's literally one line of code. And the only thing we do here, we're going back to using our amazing F strings. And we're saying, here's our string. And we just need a part of it. So we're using these square brackets, and we're going to say start with this position and end with this position. And these are the characters we are interested in. We're doing this +1 here because 27 is not included and 102 is not an inclusive number. It will count from 22 to 26 inclusive and from 97 to 101 inclusive. So we're making sure we're getting this final character. Okay, that's how string slicing works. We have just a space here because we need 2 words. And then we do the same. We're slicing part of the string. Second word coordinate and second word end coordinate +1. Okay, let's just run that and see what we get. And that is what we get. And that definitely looks like a phrase that Rosalind showed us. Okay, so that looks great. Let's go back to Rosalind and ask for our data set here. And it should return a string. So let me open this up. Okay, so I'm going to copy and paste that into our code so you can see what I've got from Rosalind. So this is what Rosalind returned, this very random looking string with a dot at the end. So let me copy or cut it and paste it in the place of our old string. Here it is. And these are the coordinates of the first word. We're going to copy them here. So here we go. And let me remove this so we don't get an error when we run our code. Let me save this and let me run the code. Okay, so this is what our coordinates returned. Let's copy this and go back to Rosalind and paste it in and see if it is correct. Okay, it seems to be correct. So again, this is called a string slicing, and I'm going to link to that video too if you're not really sure how string slicing and F strings work. Okay, so let's go to our next problem now. Conditions and loops. We need to go from A to B and add all the odd integers from A to B. So this is a very easy problem, as you'll see in a second. Let's go back to our code. And I have my snippet ready here as well. Let me copy and paste that now. Okay, so conditions and loops. So these are the default values we got from Rosalind to check our code. So it starts from 100 to 200. Of course, we are going to do +1 because we need to make sure that 200 is included. So there are two ways of solving this problem. This is kind of a classic standard approach. We're going to loop through. Let's make sure that this code works first, and then we can try optimizing it and literally making one line of code out of these three. So let's run this code first and see if it returns the value that Rosalind suggests. Okay, so it's 7,500. So what are we doing here? We're just looping from start position to end position +1. Okay, so here we are using a modular operator. If you're not sure what a modular operator is, I'm going to link a video right now. So all it does, it takes x position and divides it by 2. And then we're checking if the remainder is 0 or not. So if it is not, it is an odd number, and we accumulate that in our result. So it starts from 100, it divides it by 2, and the remainder is 0 because you can divide 100 by 2, which is 50, and the remainder is 0. So next one, in the next iteration of the loop, x will be 101, and of course the remainder is 1, and it's not equals to 0. And that way we're going to add 1 to our result, and we are going to go through this whole loop and add the values of x. Okay? I also mentioned we can do that in one line of code. It is not as easy to understand and read as this nice and clean for loop, but nonetheless, let's see how we can use list comprehension to do this same thing. So what we can do, instead of doing result here, we can basically comment this out for a second. So let's redefine result, because that's the variable we're printing out. And we can use our x for x in, and we can copy this whole thing here. And we can copy the condition here as well. We don't need this semicolon, okay? So result has to be a one single value, an integer, which is an accumulation of all the x's that met this condition. So if we're going to run this right now, we're going to get a list of values. Okay, let's see. We are actually interested in accumulation of all of these values. We want to add up all of these values and return one final integer. So this is easily done by using built-in Python sum function. It is just going to sum up all of the values from that list and return a single integer. Let's try running it again, and we can see it is 750. But just to make sure it's much easier to read, let's use our loops. Even though you could kind of split it like this and it still looks nice and tidy, it is up to you which one you want to use. Experienced Python programmer will of course understand that this is exactly the same as this. So let me just comment this out, and let's use our original loop, which is easier to read again. Okay, so let's go back to Rosalind and request our dataset. Okay, I'm going to open this file right now. Okay, so these are the values I got. Let me replace the default values with these. And let's save and run our code, and that's the value we have. Let's go back to our Rosalind portal here and paste back in, submit. Okay, that looks great. Our code works as expected. Let's go to our next challenge. Okay, so this is a bit more interesting than all of the previous ones. Definitely not 1 or 2 lines of code. So working with files, this is definitely very important because we are going to be reading and writing files a lot. All of the genomic data, DNA data you are going to get from the net will be from a database in a very particular format, or in large text files or CSV files. A lot of different formats are available. So we have to make sure we can at least read and write from the file. So all we need to do here is we are given a file with a text in it. So this is an example text. And the output has to be a file as well. So as it says here, a file containing all even numbered lines from the original file. So here we need to do exactly the same thing as in our previous problem, where we need to calculate odd or even numbers. And we already know how to do that. So let's do that. Let me copy this example text and let's go back to our code. Okay, let's create a new file and call it an input.txt. Okay, and copy the text into that file and save that. So here is our code. We are going to store the values that we read from a file as a list. It's so much easier to actually navigate through the list and work with list entries. So here we are opening a file called village.txt, which we just created. Here it is. And we are opening it in R, which is read, as F. And then we are using a list comprehension here again, and we're using this enumerate function. It is going to return every single line from this file, and it is going to return a second value, which is a position. And that is what we need to make a decision if it is an odd numbered line or not. Okay, and this f.readLines is going to read all of the lines from our file and dump them into the list as well. Okay, let me actually comment this second part out, and let's see what output will contain if we're gonna run that. Okay. So basically, all we are going to do here, we're going to read all of the lines and only save odd numbered lines in our output file list. Let's run it and see what we have. Okay, so these 4 lines we are getting back, they are yes and bravely he. This is exactly what Rosalind showed as a sample output. So our algorithm seems to grab correct lines, right? So let's try dumping that into our file as well, because that's what Rosalind said, we need to dump the result into a file. So here we're doing exactly the same thing as in our previous piece of code, but instead of reading, we're opening our file with write permissions. So we need to write our stuff, and that's even easier. We're going to say file and write into the file, and we're using our join method here again, and we need to join all of the lines from this list here. But let me go back a little bit before we run this code. We can see that the lines that were read from the file in this piece of code, so we have these /n characters, and if you're not sure what they are escape characters. They will not be written to a file when we write it right here, because they will mean that it is a new line, and our file is going to have these as a new line sentences instead of all in one line sentence. Let's look at the results and you will see what /n means. And as you can see, this file doesn't exist yet, this output.txt file. So if it doesn't exist, write mode will actually create a file for us. Okay, so let's run our code right now and see what it produces. Okay, so we did print this out, but we don't actually need that. Let me remove this part of the code, and I'm gonna save it. And we can see that we have a new file called output.txt. Let's open it up. And you can see that it is exactly the same as what we've seen in the list. And of course, /n is not here because that meant a new line. So it creates a new line. So these are called escape characters. So our code seems to work just fine. But before we request dataset from Rosalind, let's clean up our files here. Let's make it an empty file because we're going to be pasting the text that Rosalind is going to give us as a dataset. Let's go back to Rosalind now. Okay, let's get our dataset. All right. Let me go back to the code so you can see what Rosalind provided. We are going to paste it into input.txt, so there's quite a lot of text here. And again, you're going to get your own random text. Let's save this and run our code now. Okay, so we didn't really get any output because we removed our print statement, but let's look into the output file and we can see that there is something in it. So now we're going to paste this answer right here and click submit. So this has been solved correctly, and we can move on to our last challenge in Python Village part. So here we are given a sentence and it has a lot of spaces in it, which is a proper sentence, and we just need to count words in it. So we can see lowercase we with lowercase w has been found twice, which is 1, 2. Word tried has been found 3 times, 1, 2, and 3, and so on. So let's go back to our code and see how we can solve this problem. Let's close these text files, we don't need them anymore. Let's save this just to make sure, and let me copy and paste my snippet here. So this problem can be solved in 2 ways as well. We can use a for loop approach, or we can use collections counter. Let's try the first approach first and make sure our code works. So here we have our string, we copied that from Rosalind, and we're going to store a result in a dictionary. We're going to find the word we're going to write that into a dictionary as a key, and the value would be how many times it was found, and we're going to keep incrementing it by 1 every time we find it. So that's a very easy logic. So here we're just looping through our test string, but what we're doing here, we're using a split, and we're splitting it by spaces. Let me actually comment this out for a second. If you're not sure what split does, let me copy this part here and actually print it out for you. Okay. You can see that it returns a list, and it's so much easier to go through the list after we converted our string to a list and just count words like that. So let me uncomment and go back. And of course we need to print out our dictionary. We're going to use for loop here as well to print it out. So here we're going through keys and values. Keys would be words, and values will be number, how many times they were found in that sentence. Or the list, because we converted that into the list right here. And of course we have to use items, because dictionary has items, which are keys and values. And we're printing out keys and values. Sorry, I did not save that. Let me save and run it again. And we can see that we get exactly the same result as Rosalind. You might get a result that is in a different order. This is not a problem. Rosalind actually states that it only cares about the words and the count, and doesn't care about the order of the words. Okay? But before we move on and request our data set, let me show you how we can use counters. So let's include from collections import counter. So now we can comment this out, including word dictionary. So let's copy the name of this variable, because dictionary will be created on the spot when we run our counter, so we don't need to predefine it like we did here and then populate the data in that dictionary in this loop. Here it will be created on the spot, so counter, and we're going to give it exactly the same list as we gave to our for loop. Okay, let's save and run. And of course we get exactly the same result. Again, if you know how counters work, it's a great tool to use, it's quicker, it's easier to read, and it's literally just one line. It probably will be faster than your for loop here, because you do 2 statements here, like one if and one else statement. You do 2 checks in your loop. Okay, but for simplicity's sake, let me comment this out and uncomment our original code. So I even titled that here as a generic approach, and let me copy the comment I had in my snippets here, so you know what this approach is. Optimized Pythonic approach using collections module. Okay, so let's go back to our Rosalind here, and let's request our data set so we can solve this problem. Okay, I'm going to again copy and paste this long string that Rosalind provided, so you can see what it is. We're going to replace this temporary string with what Rosalind provided. So it is a very, very long string. Let's save that and run our code, and let's see what we get back. Let's copy this now and give it back to Rosalind, and let's see if it is happy with our results. Okay, we're here now. We're going to copy and paste and submit. Okay, it is happy with our result, and it's great. So this is it for this video. We can go back and we can see that we solved all of the 6 problems because they are green here. Let's go back to our account now, and we can see that we earned a couple of more badges here. And you can always just point and read what the description of these badges is. I also wanted to add one point here. I strongly recommend going through these problems by yourself, and if you're stuck, you can always go back to a video, watch the video, and see how the problem was solved. The other very cool thing is, when you solve a problem, you can always go back and click solutions here, and here you can see different solutions by different people. And it is definitely interesting and definitely recommended to go through and just read about how people solved that problem, and you'll be surprised in how many different ways this particular problem can be solved. Some people solve it in literally one line. Okay, so if we just scroll here and see some of these interesting solutions That's very similar to what we did. Okay. Yeah, there's many pages. You can always leave your solution and discuss your solution with people. This definitely is encouraged and recommended. In our videos, we're not really trying to squeeze 5 lines or 6 lines of code into 1 or 2 lines of code, even though Python definitely allows for that, but some of that code might get very unreadable and hard to maintain, and if you come back to it a couple of weeks later, it is really hard to understand what did I mean with this code that it was supposed to be 6 lines of really easy to read code, and now it's like literally 1 line. So the latest changes in Python Village have been added to our GitLab repository, so you can pull it down and look at the code. Okay, so this is it for this video. In our next video, we are going back to our DNA toolkit. We're going to write a couple of more functions that we can use on Rosalind platform again. If you have any questions about this video, please leave them in the comment section below and consider joining our Telegram and or Matrix community. All of these videos will also be available in a library platform from now on. Until next time, Rebel Coder signing out.